One last thing that I have to mention is that we proved that the slope, because derivative is just simply a slope, uh, when we go in the direction of v of f at point x0, y0 is the gradient of that function at point x0, y0 multiplied dot product of simply multiplied v. But we also said that these are two vectors, right? Two vectors, because we can also describe the gradient descent as a vector, because vector has two components, and this also has two components. Then it means also it has a direction. And gradient descent simply means that this vector is the vector along which, if we move, it will cause the fastest change in the function phi. And then it should correspond to the biggest slope, right? Then this slope should be the maximum. So the gradient, this doesn't change, but what is this vector? How can we find this vector along which, if we move, it causes the fastest change in the function f? So it simply means a dot product, and we can write a dot product like this as well. The dot product is the length of this vector, the gradient vector, multiplied by the length of this vector v, and multiplied by the cosine of the degree between those vectors. And geometrically, what does it mean? The dot product and this, what does it geometrically mean? We can plot this in a two-dimensional graph, and let's say this vector represents the gradient vector. This is the gradient vector. Let's symbolize this as vector v. Now let's say this is the vector v. And what happens when we take the dot product of these vectors? We simply take this vector v, and then we project this vector onto this vector. Let's say, so projecting simply means that we draw a perpendicular to the other vector, and this area is simply a v. And as you can remember, we were looking for the maximum value for this. So which v should we choose in order to maximize this equation? And you can see as v, this is the degree angle between these two vectors. As we decrease this angle between these two vectors, our projection will get bigger. For example, let's take this, and we are only interested in the vectors which has the length 1, because we are not interested in the length, we are interested in the direction of the vector. So we say the whatever the vector v is, its length should be 1. And let's say we take this one with the same length, and if we project, then you see it's bigger. If we take this one, like this, then it's even bigger. So as we get closer, to this vector, uh, this simply gets bigger. So what does it mean? It means the vector v causes this equation to be the maximum is the vector that is parallel to a. The parallel to, if it's parallel to a, so a was the gradient vector, then if we just find the direction of the gradient vector, if we just find the gradient vector, it means this direction will cause the fastest change, the most drastic change in our function.